Today we're going to talk about GitOps, which may be a topic you've heard about. So we're going to explore GitOps as an approach to that. Specifically today, we're going to look at a Kubernetes environment and tooling that exists for the Kubernetes world. But these concepts apply broadly. There's concepts here that you could take to other environments. So keep that in mind as we go through. Before we talk specifically about GitOps, I want to review some Kubernetes basics. I think this, at least a subset of you all have heard from me and other places and probably have experience on your own of dealing with Kubernetes. But just to make sure we're all sort of level set on some of the core things we're going to use to explore GitOps, I want to go through some Kubernetes stuff first, real briefly. So Kubernetes, what is it? It's a container orchestration engine. It's the idea that we want to manage deployments of containerized applications. And by manage, we mean things like scaling, deployment strategies, how we handle failure, how we handle monitoring, right? All the things that go into just running a container and managing it at scale in a production environment, right? Any of us can take a Docker container and run it on our desktop and it runs easy enough. But when you try to scale that out in an enterprise and have dozens or hundreds or potentially even thousands of containers, Kubernetes steps in as an orchestration model for allowing us to sort of get an insight into that and manage things in a consistent, organized way. This is, Kubernetes is straight out of the Cloud Native Computing Foundation, hosted by them, and obviously has a lot of backing and a lot of steam behind it. Kubernetes manages workloads through manifest files, okay? There's a lot of different resource types. We're going to look at 4 today because those are the 4 that kind of are pertinent to our discussion. But these are resource files that are static, generally YAML. They could be JSON, but generally you're going to see them defined in YAML. And they indicate the type of resource you want to allocate into the Kubernetes world and the desired state of that resource, okay? So these, you can just think of these as static files, and we'll look at some examples as we move forward because that's what we're going to build our GitOps routines on. So the first resource we want to talk about briefly is the idea of a pod. A pod is really, it's the smallest scalable deployable unit you can manage or deploy in Kubernetes. And really, you can kind of think of it as a container. Okay, the pod is really a group of 1 or more containers. So it's something that I can scale. I can start, I can scale, I can stop together. Generally, it's going to be 1-to-1, 1 pod for 1 container, but there's no reason it has to be. And there are use cases where you could have multiple containers in a pod. Again, it's really based on how you want to deploy and scale those. If you want to scale multiple containers together, then it makes sense to group them together in a pod. But think of a pod, just for your purposes, if you're not familiar with Kubernetes, as a container. Then the next topic is deployments. This is another resource type in Kubernetes. And this really just declares the desired state for a set of pods. So we just talked about pods being containers. A deployment saying what image I want to run, how many replicas do I want, what environment variables need to be set for that set of pods? How do I want to mount volumes? What's my deployment strategy? Do I want a rolling or a recreate strategy or some sort of custom strategy for deployment? Anything that goes into how I take a static image and get it running as a container, and whatever configuration is involved in that can be defined in a deployment type in Kubernetes. Then we have the idea of a service. A service is really just an abstraction in front of a set of a logical set of pods, okay? And it really defines a network service and the policies by which those pods can be accessed. This is really the server-side implementation of how we would do service discovery, right? You guys might have seen service discovery done on the client side where I've got some sort of manifest or some sort of list of pods that I want to load balance across. In the Kubernetes world, we do that with an abstract service on the server side. And this really can act as a load balancer sitting in front of a set of pods. So if I've got 2, 3, 4 scaled containers in a pod, then I can I can stand up a network service in front of it that will automatically load balance across those, thus giving me service discovery to some abstract set of pods as they come up and down, right? Pods and containers are ephemeral. right? Meaning that I can take them up and down as I wish, meaning that they're going to have a different network address every time they come up and down. And therefore, I wouldn't want to build some sort of point-to-point communication from one pod to another, or from one external access point to my internal pod based on a pod address. That's where this service would come into play. Services themselves are only accessible within the cluster, but once you add an ingress or a route on top of that, that's giving you an external access. It's really just giving you an external DNS name to route traffic through a service, through what we defined as a service on the previous slide. So this is what allows you to get traffic from applications or consumers outside of the cluster inside the cluster. Network traffic is limited to internal only by default. So if you don't define ingresses or routes in a Kubernetes world, routes are in an OpenShift world, then you can't get traffic into the cluster. It's walled off completely. Based on those four things, I want to look at an imperative approach to deploying applications in a Kubernetes world. So let's run over here to an OpenShift environment real quick. I'm going to use OpenShift today mainly because it presents better. It has a nice graphical interface where you can see what's going on, unlike Kubernetes, whose console is much more primitive and it's really based more on a CLI approach. But know that OpenShift is Kubernetes, right? So everything I can do in Kubernetes, I can do in OpenShift. And I can actually do a few more things in OpenShift than I can do in Kubernetes because it's really an extension model over the top of Kubernetes. But everything I'm doing today applies directly to Kubernetes native as well, okay? So what we're looking at here is two, what we call projects, or in Kubernetes, we call them namespaces. And it's really just a subdivision of workload. So if I look at my development workloads, you'll see that I don't currently have any. And if you look at my production workloads, you see that I don't currently have any, okay? Oftentimes in a real world, unlike my little fake mock demo world today, I would have a separate cluster to house production, and I would house all my non-prod things in one cluster, all my prod things in another cluster. At least that's how it's typically done. But I can really segregate my namespaces however I want, okay? I could have development, test, release, staging, pre-prod, whatever I want to call my namespaces, and completely isolate those workloads from each other. So having a production and development in the same cluster by no means is wrong or undoable, and it makes for presenting in this style much easier. So we're going to look first at simulating production workloads, okay, in an imperative way. So I want to install an application into this production namespace, okay? And the way I want to do that to start off with is, again, I want to talk about this from an imperative angle first and look at how we would do this. So I just defined in the slides as we talk through it how Kubernetes resources are defined. They're defined using YAML syntax, and they're really creating multiple manifest files per type. So you see in YAML land, I can say ///, and that really is starting a new file. So I can put multiple things into one file in a YAML format. But you'll see here I have a service defining my load balancer. I have a route defining my ingress for my application. And I have a deployment defining what pods I want to create and deploy, okay? And you'll see in my deployment, I'm saying I want to deploy this image. Keyhole software now playing API 100, and I want 2 replicas of it, and there's other things, what port I want to expose. Anything that I use to define how I want that thing to be deployed would show up here in my deployment, okay? This is actually going to be the same app that Matt Werger used for his GraphQL talk last week, okay? So it's our now playing app. We've kind of started trying to use that all of our demos, some cohesion there across things, okay? So there's 2 pieces to this app. There's an API side and a UI side. You'll see in my UI, I have a similar manifest file. And over here, I'm saying I want to deploy the UI image. Okay, and I also want 2 replicas of it. And I want it on port 8080. Okay, so I have 2 manifest files. I can come out here using an imperative approach and say OC apply API manifest. Let's get back over here. And when I run this, you're going to see that out here, forgot my -F. dash for file. I'm loading it from a file. Out here, you'll see that in my production workspace, it deploys 2 pods for me, okay? And if I look at those, I have 2 pods running. I can see the logs of those pods, right? Those pods are running. And I can actually come out here and hit that via the route, okay? So here's my Now Playing API up and running. This is not a demonstration of Kubernetes per se. I just want to make sure you can kind of follow along with GitOps in a moment. Everybody okay so far? If not, holler and I'll be quiet for a minute. So we've got our Now Playing API running. Now I can come out here and do a similar thing for my UI. And you'll see my UI will pop in out here. It'll create those containers. It also creates my service and my route. So as you look at it, this is my deployment that I defined in the YAML. This is my service, defining a load balancer over the top of my 2 pods. And this is the route allowing ingress from the outside. If I hit this app, you'll see that I bring up my Now Playing app. The Now Playing UI is obviously calling the Now Playing API using GraphQL syntax to make those calls. So pretty simple. I can come out here now and I can do things like scale my pods, right? Or I could come out here and say, from a standpoint like this, say OC scale. If I could get I could scale it to 1, and you'll see that it scales to 1 over here, right? I can come out and I can say I want to change my image. Let's say I have a different version of this app, or I'm upgrading my version of this app, and I want to add a popular link to my Now Playing app. I currently only have 1 subdivision, and I have Now Playing. Let's say I want to put a popular movies category here. I've already built that in an image, let's say. I can come out here and say, patch this current guy with that, and you'll see that it'll come out and restart my pods. It redeploys. Right? And if I go back to my application, you'll see now I have a popular movies category, right? So really I can do anything I want with this deployment, and I can do that through making imperative commands like scale or patch or do this or do that, add environment variables, right? I can modify that deployment on the fly. Does this all make sense so far? Okay. So let's delete this now and go back to our slides for a minute. Because we're going to do this in a different way. So I just went out and I cleaned up my production workspace. I don't have any running applications anymore. You'll see over here, my app is dead, right? So let's go back here and talk about what we just did. So we took an imperative approach to deployment, okay? And Webster defines that as giving an authoritative command. When I use an imperative approach, I'm saying what I want to do, but I'm also saying how I want to do it. I say things like scale the number of pods, or change the image to this, or deploy this image would be a better way to say that, right? So my analogy for that is a TV remote control, right? Where I can automate things. I don't have to get up off the couch. I can automate things by giving a command through the push of a button to say, change the channel, increase the volume to a certain level, start recording, right? Change the brightness on the television, right? I can do these imperative commands, and it's effective for getting myself to my desired state. But it breaks down when I start to drift away from my desired state. So my analogy is when I get up off the couch to refill my drink, my wife grabs the remote, and when I come back, it's now on HGTV, and the volume is a lot lower because she hears a lot better than I do, right? If I want to get back to my desired state, I have to recreate or sort of replay all of the commands I gave it up to the point where I want it again, right? I got to change the channel back. I got to change the volume back. Whatever I had done to get it to my desired state has to be redone, right? And I'm not bagging on my wife, I promise, because I like a little HGTV myself. Nothing wrong with Hometown, pretty good show. So the challenges with this approach are that there's no monitoring, alerting, self-healing, no way to automatically fix drift from my desired state beyond replaying all the things I've already done, right? There's no way to know that I'm different without either looking at it or having some sort of error that indicates something's wrong. There's no automated recoverability of that, right? So I don't know that it happened, and I can't, once I do know that it happened, I can't really recover from it in any automated way. Again, I have to replay all the steps that I've made up to that point. There's no audit trail of what changed, right? I don't have any inherent way to know what changed with my infrastructure or my deployments in any span of time. And there's no way to reliably reproduce or clone my state from one namespace or cluster to another namespace or cluster, in this case of Kubernetes, right? The current state is really just an amalgamation of everything, all the imperative commands that I've given it to date. And there's no way for me to know or guarantee that it matches my real desired state beyond it seems to be working, right? And once it stops working, then I got to figure out why is it not working and what has changed. So what we want to look at is a declarative approach to do the same thing, okay? And Webster defines that as a statement in the form of a declaration. So when I use a declarative approach, I'm really specifying what my desired state is, not how to get it into that desired state. I'm just saying, I want this to be true. I want the number of replicas to be 3. I want the image to be on version 1.1.0, right? Whatever the case may be for how I'm changing the deployment, I just declare what I want, and then I rely on some system to automatically make it so. So my analogy here is like a thermostat, right? I declare I want my house to be 70 degrees, and the system or the automation behind it maintains that desired state by whatever steps necessary to get it into that state. Okay, I don't really define that in my declarative format other than what I want. I don't declare how I want it to get that way. So advantages of this are really all the disadvantages in reverse of the imperative approach. The system can know when it has deltas or drift, and it can automatically self-heal itself into that desired state. I can recover automatically because my desired state is at all times. Okay, it's declared. And it provides an audit trail of state changes. So when I declare, when I must declare or use a declarative approach to do operational changes, I inherently have an audit trail of those state changes, and we'll look at this in a minute. And I can monitor and alert when I do have deltas or drift away from my desired state. I can know when that happened without waiting for something to go wrong. This is where GitOps comes in. So GitOps is a term coined by a guy named Alexis Richardson just a few years ago. Alexis he's currently the CEO and co-founder of Weaveworks, which is a sort of a GitOps and automation software company. His probably larger claim to fame is he's the chairman of the TOC at the Cloud Native Computing Foundation. He co-founded Rabbit. He's done a lot of things if you look him up. And I only tell you that not because I know him well or anything, just so you know, the guy's been around. He's got a lot of thought leadership in the past and currently. So this is pretty good stuff, and it's really taken a grip on the automation space. But GitOps is the practice of declaring the desired state of your infrastructure or your applications, really everything you want to automate, into a Git repository, and then using some sort of automation system to ensure that that desired state's always maintained. Okay, I'm going to turn my pointer on here so I can see it. Git works well in this space because several reasons. One, most people use it anyway, right? Most development teams are using Git. It gives us an inherent audit trail, right? As I make commits, that's what Git does, right? It tracks changes over time through commits. It gives us tagging and versioning. And the beauty from an operational standpoint is anyone who understands how to do a pull request can make operational changes to a production system or development system for that matter, okay? So really, to make changes to any given operational system, I only need to know how to do a pull request, right? If I can issue a pull request, somebody can approve it, a Git repository gets updated, my automation will take care of doing those deployments. There's 4 basic principles behind GitOps. The first being that the entire system is described declaratively, okay? So everything that I want to be able to deploy, monitor, and maintain is described declaratively. If I had a disaster and I lost my entire data center, or my AWS instances tanked for whatever reason, I could stand up a new data center, push a button, and all of my automation would take care of deploying everything that I had described declaratively again, right? So from a disaster recovery standpoint, it's beautiful. Second principle is the desired state is versioned in Git. So whatever, I describe it declaratively, but then I stick it in Git, right? I'm maintaining it in a Git repository. Third principle is the approved changes can be automatically applied. This is where the automation comes in, right? So as pull requests get accepted and merged into whatever branch I'm calling my master or main branch, they will automatically be deployed through some automation system. And that's what we're going to look at next. And I have some sort of software agents to ensure correctness and do something when I drift or diverge, right? When things diverge, I want both sides. I want something on monitoring my Git repository to say deploy this. I want something monitoring my cluster saying, hey, this changed, go back to what the desired state was, right? I want both ways to happen there. This is why we're going to look at Argo CD, okay? Argo CD is built for this. It's a declarative GitOps CD tool built specifically for Kubernetes. It automates Kubernetes deployments into some specified target environment. Okay, so I can stand up an Argo CD environment and have it deployed to one cluster or multiple clusters, however I want to configure it. It monitors those deployments and it ensures that my target environment, whatever Kubernetes cluster and namespace I specify, is always in the desired state. Okay, and then I can configure it to automatically deploy, automatically heal, or if I wish, simply report on divergences or drift and manually do my deployments. So we'll look at both options today and talk through that a bit. It's going to monitor my desired state from the following source types. We're only going to look at these top two today, but the others are options as well. I can use plain manifest files like I did with my imperative state, right? Where I just have manifest files that are static, declared, and I can use those files directly. Or I can use a Helm chart approach where I'm using more of a template-based approach. And we'll talk about advantages of that as we move into that. I can also use customize if you're familiar with that. It's a template-free approach to doing some of the same sorts of things you can do with Helm. I can use JSON, which is a Google initiative for just sort of generic data templating, really doesn't have anything to do with Kubernetes, or KSonnet, which is now deprecated, by the way, but it's a Kubernetes-based approach to JSON, essentially, but it's been deprecated really in lieu of these other options. So let's look now at a declarative approach. So let's go back to our example out here. So in reality, when I started with just my manifest files in the first imperative demo, I really already declared what my desired state is in a declarative format. It's just my approach to deploying it was imperative, right? I'm deploying it and then I'm scaling it and changing it, when really if I want to change it, what I should be doing is changing this manifest to reflect whatever it is I want to change, right? So I've got that version control and I've got some sort of audit trail behind what it is I'm changing, okay? So we're going to start out by just using these same files again. Notice I got a manifest example folder and I have an API folder and a UI folder, okay? Over on the Kubernetes side, I also have Argo CD installed, okay? We're not going to talk about installation today because it's not that interesting, but just know that this is an application or a set of pods running in my Kubernetes cluster. And once I get those installed, it gives me a console to sort of view into what Argo is doing from a GitOps perspective, okay? So I can come here and say, I want to create a new app. And I want to create my API first. It asks for a project. My project is really just dividing things so that I can filter over here on the left. So I'm going to stick it in my production project. I can choose whether I want manual or automatic syncing. For demo, for first run here, I'm just going to select manual so we can see what's going on. I can specify my GitOps URL. This is my source for my GitOps. That is where this lives. I should have pointed that earlier. This is my GitOps demo, and it is checked into the main branch of a GitOps repo on GitHub. That's at this address, okay? So this is the Git side of my GitOps, right? This is where I defined my declarative manifest for what it is I want to deploy. I had that in a main revision, and my path that I want to deploy from is manifest example API. That's manifest example API, right? So I'm really just pointing Argo to this repository, to this folder, this API folder, and saying, I want you to deploy this to my local Kubernetes cluster where Argo is running. I could put other targets and target other Kubernetes clusters if I wish. And I want it to go to the production namespace. Okay. When I say create here, you're going to see it's going to create a tile here, and it's immediately going to say it's out of sync. If I come here and look at it, you'll see that it looked at this that manifest file. It found my service, my deployment, and my route. Okay. If I look at this, I can say, what's the diff here between what is desired and what is live? Well, I desire to have this service there, and I don't have anything at all. Okay. And again, I put this into manual mode so it doesn't sync automatically. So that's why this is out of sync, or yeah, out of sync immediately. Here's my deployment, and here's my route. Okay. So now I have this manifest file. Argo is monitoring it and saying, I'm going to capture this desired state you've declared in this Git repository, and I'm going to deploy it to the cluster you specified. So if I come here and say synchronize, you're going to see it's going to do the same thing it did before, where it's going to come out and deploy that for me. All right. So now I'm in my desired state. Let's do that one more time, but let's do it slightly differently this time, and then we'll talk about some benefits of this. Okay. So I deployed my API, right? Here's my API running, but I need to deploy the UI. So I want to deploy this folder. Because this is Kubernetes native, I can actually use a Kubernetes manifest to control Argo as well. Okay, this is going to be a little bit of a brain teaser, but I can use Argo to control Argo. Okay, it's like eating your own dog food kind of thing, right? So I can declare this manifest in the Git repository, and then if I wished, I could define an Argo application that watches for all new applications and deploys those automatically. Okay. In this case, I'm just going to come out here and say, I want to deploy my Argo UI manifest. What did I call that thing? Now playing UI manifest, if I could type. And when I do that, you're going to see over here in Argo, it's going to create a manifest, UI manifest for me. Okay. I also had it turn on automatic syncing when I did that. And so it automatically deployed my UI out here. If I come down to resources now, my application's running, right? I can go through my application. So now if I come here and I say, I want, like I did before, I want one pod. Watch what happens. Argo says, nope, you said you want 2 pods. And it kills the 1 pod and automatically goes back to 2. If I watch that a little bit closer, actually, let's do it on this one, which is not syncing automatically. If I come here and say I want one of these, it will let me. If I come over to Argo now, Argo will say, hey, your API is out of sync. If I look at it, notice this one's yellow. What's my diff? Oh, my diff is that you said you wanted 2 replicas and you only have 1, right? And I can come out here and sync this, and you'll see that over here, it goes back to 2, right? Or I could come back here and say, I want to always sync automatically, and I want to self-heal anything that happens on the Kubernetes side. So I want to deploy automatically from the Git side. I want to self-heal any drifts that happen on the Kubernetes side. All right, so if I come back here now, I try to go up to 4 or 5 or 6 or 7, right? They're going to start, and then Argo is going to say, no, I don't think so, and go back to 2.
So Jamie, can I ask you a question there really quick?
Sure.
So if I process that right, that means that the sync auto sync feature is just the kind of monitoring and comparison of what you asked for and what's really happening. But I didn't realize until just then that the actual healing process is a separate flag to auto heal. Is that right?
That's correct.
Okay.
That's correct.
When the syncing gets, I assume that the answer here is yes. When the syncing part of it happens and it finds something out of sync, is there monitoring notifications that happen as well?
Yes.
You can tie in? Okay.
Yes. So I can set up alerts on this side to say, if this thing goes out of sync, fire a message onto a Slack channel, send me an email, right? Lots of different options there for alerting. Yes.
All right. Thank you.
You're welcome. Good question. So that's really what's going on. So to sort of carry this one step farther, the key here is anytime I want to change my deployment, what I really need to do is change my Git repository and let the system do it itself, right? So let's say now I wanted to do what I did on the imperative side. I want to deploy my new 1.0 change, and let's say for whatever reason I want to default to 3 now, right? So I can come out here and save this in my Git repository. I normally do this through a feature branch and a pull request, but for demo purposes, I'm going to do it directly on main, right? Just so we don't have to go through that process. Let's say upgraded image and replicas. Let's make sure I'm on a page over here where we can see this. So here's my UI, and here's my UI here, right? So if I come over here now and push this change, we should see that on the Argo side, it's going to say it's out of sync. There it is. And over here, now it's redeploying. It's using a rolling deployment, so it's going to leave my current ones up. This is a 0 downtime deployment, right? So my old pods are running until the new ones are up. It's scaling me up to 3. There they are. I've got 3 running. I come back out here now to my application. You'll see I have a popular link on my application now, right? So the key is operational changes that are done declaratively through a Git repository, right? Make sense? So let's carry this one step farther then if there's no other questions on that. What I've demoed is really how I would deal with a production environment, right? When I'm really just talking about runtime deployments, containers I want running, and any network access I need to put in place to get access to those things. There's no reason this premise can't be extended over to a development side as well, okay? Actually, before I go there, let's talk about one more thing. I almost forgot about my Helm issue. So on this example that I just did, I just used a raw manifest file here. If we look at these 2 manifest files, if I compare them to each other, so let's do compare selected, you'll see that they're largely the same, okay? All that's really different are some labeling, the port, ultimately the image that I want to deploy down here somewhere, right? Here's my image, what port I'm using, and some labels, how many replicas are different now because I changed that. But the point I want to make is that these manifests, a lot of times when you scale in an enterprise, are going to be very similar to each other, especially when dealing with the same tech type, okay? So if I'm doing Spring Boot deployments or .NET deployments or whatever it is I'm automating, a lot of times we're going to have a very similar set of manifests for that tech type, okay? And if I want to make sweeping changes, like let's say I want to default replicas to 3 always, or I want to change the way I'm handling my labels, or I want to use some sort of different deployment strategy where I'm worried more about my unavailable nodes or something, right? Something that's going to affect multiple manifest files. If I did it this way, then I have to literally go into every manifest and change them, right, into what I want. This is where Helm comes into play, okay? I can create a Helm chart, and let's go over here real quick. For those not familiar with Helm, that we could do a separate topic on just this. Let's actually go back here first. I can get back there. Helm is a package manager for Kubernetes. So essentially anything that I want to be able to deploy in Kubernetes most likely has a Helm chart for it, okay? It's really just a set of templates and variables that allow me to automatically deploy something. So for instance, if I wanted to find an Nginx Helm chart, there is one. If I wanted to find a Redis Helm chart, there is one. If I wanted to find a RabbitMQ Helm chart, there is one, right? There's a Helm chart for just about everything. If there's not a Helm chart for something, I can create one, okay? And I can also create them for my own internal applications to sort of take care of that common manifest problem I just described, right? As I scale, like where I am, my current client, we've got dozens, if not hundreds of Spring Boot services, all with very similar manifest files, right? So we have a Helm chart that looks similar to this, where I define a chart by saying what I want to call it. In this case, I just called this one GitOps demo. I give it a version, but then I define my templates in sort of a prescribed way. And I can have different template files, like here's my deployment YAML. This is exactly what I had over in my other file, except you'll see where I had specific things, now I've got variables, right? Where I have image, I've got a variable. So I want an image URL and an image tag. Where I've got replicas, I've got a variable, right? I can default those variables to certain things if I wish. So I can say I want a default replica count to 1 if they don't specify. But things that I don't want to default, like I always need a unique image and tag, right? Then I wouldn't default those necessarily. Okay, so I define this Helm chart and I publish it. Okay, once I publish it, then I can use that Helm chart in my declarative format because Argo CD understands Helm, right? So if I look at my API now this was my manifest API where I just had it statically defined. If I look at the Helm approach, now I'm saying I want to now playing API version 1, but I want to use version 1 of the GitOps Helm chart. And here's my values I want you to plug in. I want you to use this name. I want you to have 2 replicas. Here's the image I want you to use. Here's the port I want you to use. Don't use the defaults. In this case, I'm saying I don't want to default a route. In my UI case, I'm saying I do still want a route, which is the default behavior. I want to use this image and I want my replicas to be 2, right? So essentially now I'm not defining that entire manifest template. I'm just providing the variables that I want to plug into a more abstract template, okay? So I can do the same sort of thing I did over here. I can now come out here to my production environment. Let's delete these guys. When I do that, you'll see that they'll get deleted over here on the Kubernetes side as well. There it goes. And now I can apply my Helm approach to the same thing. Now playing API Helm. And you'll see out here, it creates my now playing API Helm. It's going to sync for me automatically because I told it to. And here it is deploying that through Helm. So really the exact same things happen. I've just sort of streamlined and made that manifest creation much more flexible. I can come here and do the same thing for my UI. All right. Should see it pop in here. There it is deploying. And now the same thing applies that I said before, right? If I want to change anything now, I'm really just changing values in a file. I don't have that large manifest that I could easily screw up, and I have to have more intelligence to understand how the Kubernetes manifest work versus just knowing these are variables which I can go in and change and tweak, right? Operational staff and lower level programmers can understand this easier than they can understand these complex manifest files, right? So that's next key. Let's carry this one step farther real quick. I also have a development workspace out here. You'll notice it doesn't have anything in it, okay? In my Helm chart, I also have some other template types in here that I didn't show you when we first came in here, right? So I have my deployment, my route, and my service, but I also had this idea of a pipeline in here. And if you look at my pipeline template, it says things like, if pipeline is enabled, right? Well, by default, my pipeline is not enabled. But in a development, because in a production world, I don't want a pipeline, right? I don't need to rebuild in production. Really, in production, I'm just deploying an already tested image. But in my development world, I want to install and use pipelines and have them trigger automatically and so on, right? So let's come here and switch to my develop branch of my GitOps demo. Develop branch, GitOps demo. And look at it's now playing in here. So I have the same chart. I'm in my same GitOps demo repo, now looking at a develop branch, right? I'm using a Git flow approach to this. If I look at my values now, I have a lot more stuff in here now, because now I need to know, where am I going to pull the source code for builds? I need to know, what is my GitOps folder so that I can update my manifests automatically? I need to know, do I want pipelines or not? And I can say, yes, I want pipelines, and I want them to trigger on code commits, right? A lot of things we could talk about this. We're running out of time, so I'm just going to do this pretty quick. But I can come here now and say, OC apply Argo CD, and now playing API Helm. Let's go out here to Argo before I push that button, just so you sort of see what's happening. Go to a development view of this. When that installs, you'll see it pop in over here in Argo. It's going through a sync. In my sync, I'm saying how many pods I want. Everything that's part of my manifest. In development, I only want one pod, right? And remember I said, oops, over here, I don't want a route. Actually, I didn't do that in development. I did that in production. Yes, so I do have a route in this case. So I can come here and say, deal with my application just like I could before, right? So that's running. The difference here, though, is that now I'm listening for code commit changes. And you'll see over here, I've also installed this other type called a pipeline. If I come down here and look at my pipelines, I've got an API playing pipe that's going to perform pipeline-like tasks when I commit code. So I can clone my source, I can build and push an image, I can update I can do whatever steps in here I want to do. Code coverage, SonarQube code smells, and code quality checks, whatever steps I want to come up with for my pipeline, I can declare in this Helm chart as my standard approach and install it automatically using Argo CD, okay? So to just last thing, just to sort of demo this, if I come over to my app, this is my React app, and let's say this is where I want to turn on my popular movies menu item, right? The current version that I have running out there doesn't have it. In fact, I need to go install UI too, I think. Let's go install UI before I do that. So back over here. Now my UI is coming in here. Should see a pipeline pop in. There's my pipeline for my UI, right? If I come out here now to my UI and I commit this change, go to the right window. Why isn't it showing? Oh, I didn't save it. That's why. If I save the file, now I'm really just adding a popular link. Added popular movie menu. When I commit this, you're going to see over here, my pipeline is going to kick off automatically. There it is, my pipeline running. If I look at it, it's cloning my source, then it's going to go through and build the image, and then it's going to deploy it by updating my Helm chart, okay? A lot of stuff I just went through there pretty quick, but hopefully you get the big idea that I can use GitOps for production, for that guarantee of a declarative approach to I'm always at my desired state, and any drift away from that can either be detected and alerted or automatically healed. But I can also use these same principles in my development environment to really scale out development teams. In my current client, we have, I don't know, 12 or 15 different development teams, all doing development in this way. And they don't have to understand Kubernetes manifests. They don't have to understand really how to build pipelines. Really just have to how to do pull requests and what variables they have at their disposal for changing values, right? They can do their development in their applications the way they always do, and all of the rest of it sort of just falls into place. I think that's all I got, so I'll take questions.
Can Argo CD perform canary deployments, or is it all or nothing?
Yes, it's not all or nothing. So I can define applications, quote, Argo applications at any level I want. So I can have it watch a single folder, a single file, an entire directory recursively, Helm charts. I can define it at any level. So yes, that's one of the features of Argo, is to do those sort of canary deployments.
So organizationally, how, you got the Argo console and scripts, and then you have the YAML scripts, you have production and prod. What role, or who is maintaining and care and feeding this platform mechanism?
So the Kubernetes platform, and I can only speak for the clients that I've helped implement this, right? There's not necessarily a subscribed one way fits all approach, but at least one or multiple times I've seen work is that you have some sort of core, what we call DevOps team, that's sort of managing the infrastructure, managing your Kubernetes or OpenShift platform, managing, in this case, the Argo platform that it's running, managing everything that has to do with infrastructure and that DevOps platform itself. And then the development teams do everything else, right? So development teams are responsible, obviously, for app dev, but they're also responsible for maintaining their own DevOps or GitOps repos, in this case, what we call GitOps repos, right? So they're creating these, right? They have documentation on how to create them, what variables are available from the Helm chart for them to override, how changing those variables affects their deployment, and so on. But there's really not a separate operations team that's taking care of the deployment side, right? Now there is, once we talk about true production deployments, we're not going to allow developers to come straight out to the main or master branch of their GitOps repo and make changes, right? Right. There's a process for that, and we use pull requests and automated change request tickets to do that. So as pull requests come in and they get merged automatically, and then the deployments go out automatically upon the approval, right? Once that pull request merges into the Git repo, the deployment's going.
So each application would have its traditional repo from the development side. It also would have a GitOps repo associated with it for development, not prod. And then they would keep the branches kind of in sync. If I added a new feature that required more declarative configuration, that would just line up, right? That would, yeah.
Yeah, that's right. And we use a Git flow approach for that, right? So the main or master branch is always production.
Yeah.
Develop branch is always develop, and that's what gets merged into like a development namespace, right? So that's automatically going to deploy. Anything that hits the develop branch is going to automatically deploy into my development integration environment. We use feature branches for local development. Okay. Once we're done with those local developments on features, we pull request those in to develop. Those changes automatically get deployed into our development environment for an integrated testing.
So gotcha. So if I have application A, I'd have DevOps A or GitOps A project, and then the master would be prod in that, and then
correct.
I wouldn't have a dev project and a prod project. I'd have just
we use Git flow to manage.
Oh, gotcha.
Those where. Yep. Yep.
Thanks.
Anything else?
I'm trying to think a couple steps ahead. I think this fits really well with my client in the cloud work that they're doing now. It's a big adoption. The demo is pretty impressive. One of the questions I have is kind of twofold. One is, what's the counter argument to this? I mean, how could you ever look at this thing and go, wow, we would never adopt that because of these things? What would be the negatives or the counter arguments you would think of using a tool like this? And the other question is, what happens when chaos ensues? Like, it's unable to spin these things up. You say, I want 3, and for some reason it's not working. There's a million reasons why it may not be able to get to 3 instances or 3 pods or whatever. Or you've got some other bigger production problem happening, like you're getting a massive DDoS attack and they keep coming down and going up and coming down. What do you do in that scenario when the happy path doesn't work?
Yeah, so the short answer to the last part is that this isn't going to cause you any additional chaos beyond what you'll already have. Meaning that if you used an imperative approach to try the same thing and any of those conditions exist, I couldn't scale to 3 for something, it's going to happen. Ultimately, this will just end up out of sync, right? If you turn on alert, you'll know that out of sync is happening, right? Once that out of sync is happening and you need to disable your self-healing or your auto syncing altogether, you can just come out here and turn it off, right? And then it will stop trying until you can rectify the situation. In terms of the negative side of this, honestly, I haven't come up with anything yet. The only thing that we've tried to deal with my current client is how to best manage the for every of my 100 different applications I'm deploying. So what we've done is we've separated by team, meaning that team A dash GitOps, and then I put my applications in as folders. And then when I configure Argo, I'm really just pointing it to a specific folder. In this case, my wherever it is now playing API, right? So I think my point being that that's one thing I could see happening here is as this scales, you could end up with repo nightmare, right? Where you've got hundreds of these things and it's sort of hard to keep track of and so on for any given team. They got to have a lot of different things checked out. They got to open them in a different editor, right? That kind of stuff. So, but in terms of functionally or logistically or operationally, we haven't come up with anything yet that's been a negative, because we took the imperative approach initially. I should have pointed that out. Is our approach up until recently has been an imperative approach using Ansible. You could use Ansible, you could use Puppet, Chef, automation configuration tools like that to do that imperative approach where you say, go do this deployment, and that's what we've done. Well, we end up in those drifted situations where something's gone wrong or somebody's monkeyed something up or something's gone wrong or a deployment's gone wrong, and I don't have any real way of knowing what changed in that deployment, right? Really what it ends up being is delete everything, go back to the last known state that we knew was good and go with that, right? So this gives us that audit trail and ability to easily see what changed and roll back, which is something I didn't point out. I can come out here in Argo, probably don't have anything I can roll back to now because I probably deleted it, but I also get history and rollback. As I do multiple deployments, I get a log here, and I can simply come back here and say, if I had a second one here, I could come and say roll back, and it will automatically redo my last deployment the way it was before, without me having to go update the Git repo. If I was in an emergency situation, I deployed something went down, come here, roll it back. This will immediately become out of sync because I told it to roll back. I go fix my Git repository or fix the problem and redeploy, right? So that's something I didn't point out as well.
Cool, thank you.
Also, if you had more than dev and prod, like say you had a staging environment, would that just be a separate branch?
That's the way we handle it. Yeah. So we use dev, we use release, and we use prod, and then we have an experimental namespace for most teams. Where experimental is really free for all; they can do whatever they want in there. Dev's always pointed to the develop branch. Release is pointed to the current release branch of whatever it is I'm deploying, right? And those releases are numbered, so we'd have, for an app, I'd have release /1.0.1 or whatever, right? Using Gitflow type strategy, semantic versioning. So you can have as many branches as you want, but that is key, that you separate your GitOps by branch. All right, any other questions? Hey, there's Case.
Yeah, that was great, man.
I know it's a lot, but hopefully you could take away sort of the big ideas, right?
Yeah.
And we did record it. There's a D. Hey, D. We did record it, so if you want to go back and revisit it or ask me questions, that'd be great.
Yeah, it was fantastic, Jaime. Thanks, man.
Thank you.
Thank you, guys.